Hello, everyone. So this video is going to talk about how to identify the transformations on a square root or cube root function, as well as to graph them on a coordinate plane. Okay, so I want to start this video with kind of just a review of what all the different vertical and horizontal transformations that we know at this point are. And then we'll slowly but surely get into what it looks like after we graph them. All right. So I've kind of separated the transformations into two types. We have vertical transformations and horizontal transformations. So if you take a look at number one, if you remember, if you add a value to the outside, in this case, we're going to add the 2 to the outside. That is going to be a vertical translation up 2. Now, if we were to subtract 2, that would, of course, go down 2. So we know whether we're going up or down. Okay, so anytime you add or subtract a value to the outside of your radical, it's going to be a vertical slide or a vertical shift up or down. Okay. Now, for number 2, we take that same value, that 2, but now I'm adding it to the inside. So when I add it to the inside of my function, it's no longer going to be a vertical translation, but it's going to be a horizontal translation. And when we deal with the inside of our function, when I have +2, we have to remember to do the inverse, right? So everyone always thinks that if I were to add 2 to the inside, that would move it to the right. But in fact, we have to do the inverse direction, which is going to move it to the left. Okay, so it's going to go to the left 2 units. Okay, so again, adding, subtracting is going to be a translation. You just have to pay attention to the sign. If you add to the outside, like the first question, it would go up. If you were to subtract, it would go down. And then in question 2, if we add the 2, it would actually go left. And if we subtract, it would go to the right. Okay. Let's take a look at number 3. So we have a different type of transformation here. So this won't be a translation anymore. Anytime we have a multiplier, in this case, I have a multiplier of 2. That is going to be what's called a vertical dilation factor of 2. Oops, hang on. There we go. And anytime that my dilation factor is a value greater than 1, we have to indicate whether it's going to be a stretch or compression. In this case, it's greater than 1. We know it has to be a stretch. Okay. Now with number 4, we have kind of the same idea here, but that 2 multiplier is now inside the radical, right? So anytime we have these operations inside, it's always going to be a horizontal transformation. And in this case, because it's a multiplier, I have a horizontal dilation factor. Now, just like the problem above it when we did left instead of right, you still need to use our inverse. And the inverse of the multiplicative inverse is going to be the reciprocal. So instead of saying that my horizontal dilation factor is 2, we're going to use the reciprocal because that's going to be the inverse of that operation. And in this case, it's smaller than 1, so it's going to be a compression. All right. So whenever you do a dilation, you always need to tell me what the value is, and you need to tell me whether it's a stretch or compression for that particular problem. And also remember, when we have these horizontal dilations, any multiplier on the inside, you would have to take the reciprocal of and use that value to identify whether it's going to be a stretch or compression. All right. Now we have the last set. Okay. The last set of problems here is, hang on. All right. Number 5, if I have a negative multiplier on the outside. That is going to be a vertical reflection. Okay, and I probably prefer you to write, I have a reflection over the x-axis, right? So if I were to do a vertical reflection on something, that would fold it over the x-axis and put it on the other side in the other two quadrants. So anytime I have this negative here on the outside, that's always a reflection over the x-axis. And for number 6, I have that same negative, but now it's on the inside. So it's going to be just like any other problem we had above it. It's going to be a horizontal reflection. So if I have any operation on the inside, that's always a horizontal change. In this case, that negative is a reflection. I probably prefer you to say that I have a reflection over the y-axis this time, right? So if I fold it over the y-axis, that would be a horizontal change. Okay, so these are kind of the 6 different types of transformations that I have here. Hopefully that's a little bit of a review for you. But in the following problems, I have kind of combinations. So I have problems with a mixture of these transformations. I would like to kind of identify one by one so you guys can see what the expectation is. All right, so let's take a look at number 7. Right, I'm going to start with this 3 on the outside. So because it's on the outside of my radical, I know it's going to be a vertical change, right? So it's going to be a vertical transformation. And because it's a multiplier, I know it's got to be a dilation. So I'm going to have a vertical dilation of 3, which is a stretch. Okay. Now, the second piece that I have is because I'm adding 4 on the inside, and it's on the inside, I know it's horizontal. And it's going to be a translation because, again, previous in the video, anytime I add or subtract, that's going to be a shift. That's going to be a translation. And if I'm adding 4, that means it's going to go left 4. All right. And those are the only 2 transformations I have. All right. So now if you guys take a look at number 8, I'm actually going to transform a cube root. Doesn't change how I do anything here. It's just a cube root function instead of a square root function. This 3 on the outside does not do anything. It's just a different function family. All right. So I do have on the inside, there's a multiplier of 2/5. So because it's on the inside, I already know it's going to be a horizontal transformation. And because it's a multiplier, I know it's going to be a dilation. Okay. Now, remember when we do these horizontal ones, we have to use the inverse, right? So instead of 2/5, I know it's going to be a 5/2. And 5/2, the fraction of 5/2 is greater than 1. So I know it would be a stretch. Okay. And then last but not least, I have this -7 on the outside because it's on the outside. I know it's going to be a vertical transformation. And because I'm subtracting it, I know it's a vertical translation. And I would go down 7. Okay. And those are the only 2 transformations I had in problem number 8. So let's continue. I have 2 more problems here. You're welcome to pause the video and try to complete these on your own. I'll kind of embed some questions in Edpuzzle to see what you can do here. But I'm going to go through them one by one, and we'll see how well we can do. So again, pause if you need to, but I'm going to start trying to write all these transformations. So the first thing I have is I have this negative on the outside, which is going to be a, hold on a second. It's going to be a reflection. And because I know it's a vertical reflection, I'm going to call that a reflection over the x-axis. All right. Then I have the 2, right? So I'm going to change colors here. go. All right, so the 2 is a multiplier. So I'm going to have, and it's on the outside, so it's going to be a vertical dilation factor of 2. I don't include the negative, it's just a value. The negative was the reflection, remember. And because that is bigger than 1, I know it's a stretch. Next, I have this 7. It's on the inside. It's being subtracted. So I know I have a horizontal translation. My stylus isn't cooperating. Hang on. Translation. And that is going to be right 7. And then last but not least, we'll use green here. I have this plus 6, which would be a vertical translation, and that would go up 6. Okay. So that's question number 9. Question number 10, I continue on. The 0.5 is a multiplier on the outside. So that's going to be a vertical dilation of 0.5. And because that's smaller than 1, it's going to be a compression. So it's going to shrink my graph a little bit. And then the negative, right, next to the x, is going to be a reflection. But because it's on the inside, it's going to be a reflection over the y-axis. And then last but not least, this plus 1 at the end would be a vertical translation of 1. Okay? And those are the only 3 transformations I had for the cube root function. Again, number 9 was a square root function. Number 10 was a cube root. The square root, cube root are just 2 different graphs we're going to get into here in a minute. But all the transformations work the same way. Okay? So let's take a look at how we do these graphs. Part 3 here is creating a table and graph for a function with transformations. So at the very top here, I have the parent functions. These are the originals. There's no transformations. This is what the original graphs look like. I have a kind of a table of values here, as well as a graph beside it for each one. And if you notice for the square root function at -1, there's an error, right? So in this first table of values, at -1, I have an error because if I take the square root of a negative, I'm going to get an imaginary value. You can't graph an imaginary value on the coordinate plane. So that's why we get the error message for any negatives. However, for the cube root function, we can graph both positive and negatives. You can take the cube root of a positive value or negative value. We shouldn't get any errors. So that's why if you notice the domain for the square root function goes from 0 to infinity. The domain for the cube root function goes from -infinity to infinity. It's all real numbers. It would include everything. Okay? So what I want to do is I want to take these tables and graphs and I want to transform them one step at a time. And I want to see what the new graph would look like without the use of a calculator. So I want to see what this would be after the transformation. So for number 11 here, what I'm going to do is I'm going to start by just describing the transformations. Try to identify what the transformations in this problem are. Now this is a square root function. And we're going to have both horizontal transformations, and we're going to have vertical transformations. Okay. So the question is in number 11, what are the horizontal changes? Well, the only change here, transformation that I have, is going to be this -3 on the inside. And what that's going to do is that's going to be a horizontal translation right 3 units, right? And then the 2 on the outside is a multiplier. So that is actually going to be a vertical dilation by a factor of 2, which is going to stretch my graph. Okay, so these are the 2 changes we have. Now, if you look at my table of values, I have x and y coordinates. Now, x is your horizontal coordinate, y is your vertical coordinate. So it would make sense if I want to take my graph and I want to shift it 3 units to the right, what I'm going to do is I'm going to take all my x values, okay, and I am going to add 3. I'm going to shift it to the right 3 units. I want to add 3 to each of their values. So if I do that, the first value is 0. I'm going to add 3 to it. I'll now have 3. Next value is 1. If I add 3 to it, I'm now going to have 4. Add 3 to the next value. Now the next value is 4. So now my new table would be a 7. If I add 3 to the 9, my new value would be 12. So those are all the horizontal changes. Now we did have a vertical change, which was a dilation stretch of 2. Now remember, dilations are multipliers. Translations, we add or subtract. Dilations, we multiply. So what I want to do is I want to take all these y values and I want to multiply them by a value of 2. So if I take the first y value of 0, multiply it by 2, well, 0 times 2 is still 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. Again, I use the original parent function to get my new table of values. From there, it's as simple as just plotting some points. I know my first point is going to be at 3, 0. Then I have 4, 2, 7, 4, and then 12, 6. Now that's going to be off my graph a little bit, but what I get is I get a graph that looks like that. And that would be the new graph. That would be the graph of my new function after all the transformations. So if you can kind of see here, I do have another problem with this. We're going to take the parent function, the table for the parent function. We're going to apply the transformations that we know to that parent function. And then we just have to plot the points, and that should give you the graph. You can always check this on Desmos or your graphing calculator if you have one at home. But you should get the graph, no problem. So let's do one more. For number 12, I have a cube root function, right? So we did square root for 11. We're going to do cube root for number 12. And I have a set of both horizontal and vertical changes that need to take place. So I want to separate them just so you can see the difference. I have horizontal transformations and I have vertical transformations. Okay, so let's see what we have here. All right, now as far as horizontal changes, well, the negative on the outside, that's going to be vertical. Anything on the outside is vertical. The only thing operation we have on the inside of my radical is subtracting 1. So I know I'm going to have a horizontal translation to the right 1 unit. Okay, and then I have a vertical. I have 2 vertical changes. The first one is the negative on the outside. That's going to be a reflection over the x-axis, as we talked about before. Okay, and then the +3 on the outside would be a vertical translation up 3 units. Okay, so we had 1 horizontal transformation and 2 vertical transformations. We're going to see what that does for our table of values. So what I'm going to do is I'm going to take all these x values and I want to shift them to the right one. So I'm going to take all these x values, and if I want to go to the right one, I'm going to add 1 to them. So instead of -8, if I add 1, that would now actually be a negative. Hang on here. Let's see if I can get my stylus working. There we go, -7. And then if I add 1 to the next x value, that would be a 0. 0 plus 1 is 1. 1 plus 1 is 2. Oh, and it looks like I'm missing a row here. 8 plus 1 is 9. Okay, so that would give me all of my new x values. Now for the y values, I need to reflect them. I have two transformations. I want to reflect all the y values, so I'm going to multiply it by a negative, and then I want to shift them up 3 units. Okay, and we always follow order of operations here. You would always multiply it by the negative first, then add 3 to it. So if I take the first y value of negative 2 and I multiply it by a negative, that would now become a positive 2. Add 3 gives me 5. Okay, same thing. So you can kind of follow along. So negative 1 times a negative would be a positive 1, plus 3 would be 4, right? 0 times a negative is still 0, plus 3 would be a 3. 1 times a negative would be negative 1, plus 3 would be 2. And then last but not least, negative times 2 is negative 2, plus 3 would be 1, right? And then I can just plot those points. So I would go to, let's say, a negative 7, comma 5. So that's going to be right about here. 0, comma 4. So that's my y-intercept. 1, comma 3. 2, comma 2. There we go. And then 9, comma 1. And if I connect these, it makes a little curve that looks like this. All right. And if you compare that, so I'm going to scroll up here, but if you take a look at this image, okay, and you scroll it up to this parent function, right? So this is the original. You can see that it was shifted to the right 1 unit. It was flipped upside down, and it was shifted up 3 units. It was flipped upside down and shifted to the right ones. Okay, so my strategy for this is to identify all of the transformations that take place in the problem, and then apply those transformations to either the x or y coordinates. Once you do that, you can just plot the points and you can get your graph. All right, I hope this helped. Please let me know if you have any questions, and there'll be an assignment for you on Google Classroom.